following on from yesterday's class when we talked about building a 95% confidence interval for a mean, we're going to look now at how samples can help us to estimate something else in terms of the population. This time we're looking at how a sample proportion might be able to help us to reflect back on a population proportion. Okay, now the first thing I want to point out here is, first of all, the two words estimating and proportion. So you're estimating a population proportion. The population is always outside your grasp. It's too big to deal with, unless you're carrying out the census, of course, once every 4 years. But a population is never going to be something that's realistically there to count or take statistics from. Okay, so instead we have to fall back on samples. Now, the second word I want you to look at is proportion. What is a proportion? Well, a proportion, if I drop the first three letters, is a portion. And what's a portion? Nothing but a fraction. So therefore, this exercise we're going to look at here in this lesson is going to be about how we use a fraction of a sample to reflect back and tell us something about the fraction of the population. Okay, that's what we're going to be dealing with in this lesson. Okay, so let's have a look at what the slides say. We usually are unable to collect information about a population. We know that, so we have to rely on samples. We use a sample proportion to estimate the population proportion. So in other words, we use a fraction of the sample to help us to estimate the fraction of the population. Okay, if a quarter of the sample like ice cream, well then maybe a quarter of the population will like ice cream as well. Or I might say, well, with 95% confidence, it's between these two fractions that the population proportion actually lies. Okay, the sample must be random. Every member of the population must have an equal chance of being included. Now, what I'm saying there is that the normal conditions that are laid down for choosing a sample have to be followed. If you can't remember off the top of your head what they were, go back to a previous lesson, have a look and see, how do I choose a sample? What are the various different ways of putting a sample together? But what are the conditions that must be present when you're selecting a sample? If you can't remember them, go back and have a look. The sample proportion, now this is a new symbol, this thing here, yeah, that's actually called P hat, because it's like P wearing a hat. So we actually call it P hat. Is the best point estimate of the population proportion P. So in other words, when we take a sample and we work out what fraction of the sample is in favor of something or like something, then that particular statistic of the sample is the best point estimate we have for the parameter of the population. Okay, so in other words, if the sample say that a quarter of people like this thing, well then that quarter, that statistic might reflect back to say, well, maybe a quarter of the population like it as well. And because the quarter is from the sample, it's a statistic. Because the quarter then might come from the population, it's a parameter. So just keep the two S's and the two P's together. So therefore, we have the following. The population proportion P is what we will never be able to calculate. Okay, so therefore, in order for me to estimate the population proportion, I have to fall back on a sample proportion, which we call P hat. And P hat is nothing more than a fraction, because we're dealing with proportions. It's nothing more than a fraction that represents the number of successful outcomes over the total number of objects in the sample. So in other words, it's going to be a fraction. And that's what I said to you at the start of this thing. P hat is going to be a fraction. Now, if x over n is the sample proportion of x successes in a sample of size n, then Q hat, if you go back to the Bernoulli trials, remember P and Q, P were the number of successes, Q were the number of failures. Same kind of thing here. If P hat represents the proportion of success, then Q hat represents the proportion of failures. And a very simple thing to remember, if it's not successful, it's a failure. So therefore 1 minus P hat will be the same as Q hat. Just keep those two things in your head. So P hat is the successes, Q hat is the failures, but Q hat is calculated by 1 minus P hat. So if in a random selection of 400 students, just to demonstrate this, if 180 said they owned a smartphone, then the best point estimate of the proportion of students in the whole population would simply be that particular fraction in the sample. Okay, so how many students in the sample? 400. How many of them said that they had a smartphone? 180. What is the sample proportion? 180 over 400. What is that 180 over 400? It's P hat. What is P hat? Well, at the moment, it's the best point estimate I have to say, well, if 180 out of 400 have a smartphone in this particular sample, well, maybe that reflects back to say that 0.45 0.45 of the population, or 45% of the population, also own a smartphone. Okay, think about that again. 400 students in my sample, 180 said they own a smartphone. What's the sample proportion? What's the sample fraction? 180 over 400. Now break that down. What does that come out as? 0.45. And what's 0.45? 45%. So 45% of my sample own a smartphone. That's the best point estimate I have to say, well, maybe 45% of the major population own a smartphone too. Okay, it's the only thing I have to fall back on. So again, I'm just going to highlight the fact that we will never be able to deal with the population. We're only able to deal with the samples. And the samples, whatever statistics they give us back, they are the best point estimates we have for estimating what's going on in the total population. Just before, here's an example, just before the 2000 US elections, NBC and CNN, now they're two news broadcasters in America, asked 1,000 randomly selected voters who they would vote for. And this was the table of results. For NBC, 430 out of 1,000 said George Bush, 570 out of 1,000 said somebody else. CNN, 460 said George Bush, 540 said somebody else. Okay, now from there we have a sample proportion. So down here on this last line you'll see the sample proportion, nothing more than the fraction of the number of people who went for George Bush out of the total. There are 1,000 people asked altogether, as we were told there. So there's your 1,000 people. 430 of those voted for George Bush, but said they would vote for George Bush. Okay, so that's 430 out of the 1,000. That's p hat. Now that breaks down obviously to 0.43, and over here we've got 460 out of 1,000, which is p hat, which gives me 0.46. What does that show me? That shows me that in both of these samples there is a variation. In other words, what it verifies is that as I move from sample to sample to sample, I see a phenomenon which we called already sampling variation. Okay, that as we move from sample to sample, there will be variations in the statistics. That's why after we do the sampling, we take them all together and we bring them into one collective exercise. So p hat for George Bush, that means the sample proportion of those who said they would vote for George Bush is 430 out of 1,000. P hat for CNN is 460 out of 1,000, which is again the proportion of the sample that said they would vote for George Bush. So therefore, from the two news broadcasters, we're getting two slightly different sample proportions. How can both of those different sample proportions point back to the population? All right. Well, we've got to take it a little step further. We've got to bring in the 95% confidence interval. So in other words, if NBC say that 0.43 is p hat, and CNN say, no, 0.46 is p hat, what is the confidence interval for both of these news stations? Meaning, what are the two values, lower and higher, yeah, inside which I can say with 95% confidence, yes, the population proportion is in there. Well, let's take a look and see. Keep in mind, in order for us to work out the 95% confidence interval, it's going to be the margin of error added and subtracted from the sample proportion. So in other words, it's going to be p hat, that's the sample proportion, plus or minus the margin of error. Now, what's the margin of error for a population proportion? Well, the margin of error is on the next slide. The margin of error is this thing here. It's p by 1 minus p over n, and you get the square root of the answer. Okay, so 1.96 then would give me a 95% confidence interval. So just keep in mind here, p by 1 minus p over n. That becomes the standard deviation of the sample proportion. Now, first of all, because it's p and p, that there would be the standard deviation of the population proportion, but we don't know what the population proportion is. So therefore, we will never use p. We will always introduce this with p hat. So therefore, the standard deviation is the square root of p multiplied by p minus 1 minus p hat all over n. What does that mean? It's the square root of the fraction representing success multiplied by the fraction representing failure divided by the number of people in that sample. That becomes the standard deviation. And what is the margin of error? the margin of error is for 95% confidence? 1.96 times that. Okay, and then what's the 95% confidence interval? Well, it will be the sample proportion plus or minus the margin of error, which is 1.96 times that particular formula there. Okay, let's just move on and see if we can make sense of it. So in all questions, we have to assume a large enough sample size. That goes without saying. Okay, the confidence interval for a population proportion with a confidence level of 95% is given by the following. Now let's just think of this. The confidence interval for a population proportion. Now don't forget, the population proportion is built on the sample proportion. So I need a p hat, I need a 1 minus p hat, so I need the fraction representing success, I need the fraction representing failure, and I need the number of people or the number of objects in the sample. I need those three. Once I have those three, then the standard deviation becomes the square root of the fraction representing success multiplied by the fraction representing failure over the number of people in your sample. Okay, and if I want to turn that into a margin of error, because don't forget, this is the standard deviation of the sample proportion, so that's the standard deviation of p hat. If I want to turn this into a margin of error for that standard deviation, it's 1.96 times p hat by 1 minus p hat over n. And finally, if I want my 95% confidence interval, well then it's going to be the sample proportion for success plus or minus the margin of error, which is 1.96 times p hat by 1 minus p hat all over n. So that's how you build this thing up. Okay, so the three things we will always be looking for in these questions is, what's the fraction representing success, what's the fraction representing failure, and how many people or how many objects are present in my sample. Once you have those three, you can immediately work out the standard deviation of the sample proportion. And when you work out the standard deviation of the sample proportion using the square root of the fraction of success multiplied by the fraction of failure over the number of objects in the sample, you then can turn that standard deviation of the sample proportion into a margin of error. And because it's 95%, we're looking at the magic number 1.96 times the standard deviation of the sample proportion. If you go back to yesterday, we talked about 1.96 times the standard deviation of the sample. Okay, here we're talking about the population proportion, so keep that in mind. 1.96 is always the magic number when we're dealing with the 95% confidence interval. And finally then, if I want to use my margin of error to build a 95% confidence interval, you take the fraction representing success and you add and subtract 1.96 times the standard deviation for the sample proportion, which is the square root of the fraction of success multiplied by the fraction of failure over the number of objects in your sample. Now, again, as I said yesterday, waffle, waffle, waffle. I can talk for ages, but until we do some of these things, you're not going to be able to see exactly how it works. So this is what I want to just point out. There might be a little bit of confusion over, oh, well, when do we use P, when do we use P hat? Answer, you never use P. We don't have a population proportion. We can't get a population proportion because we can't reach the population. So we will never use that. In fact, we will always only ever use 1.96 times the square root of P hat multiplied by 1 minus P hat over n. You're always going to be dealing with samples, so that is what I would always expect to see you writing down when you want to work out, first of all, your margin of error on the standard deviation, and secondly, when you want to apply that margin of error to P hat in order to build a 95% confidence interval. Okay, so confidence intervals of 90% or 99% could also be constructed. Now, can I just point out here, if you want to build other confidence intervals, the only number that changes is the number in front of the square root, the number that you multiply the standard deviation by. So 1.96 times the standard deviation of the sample proportion, 1.96 is the magic number for the 95%. If I wanted to move to 90 or 99, I'd have a different number in front of the standard deviation. So just keep that in mind. And if they do want you to build a 90% or 99%, they have to give you the magic number to put in front of the standard deviation. So there's not much to worry about there if you're asked to build other confidence intervals. Okay, question time, because I think questions sort these things out more than waffle in theory. An insurance company checks Garda records on 500 randomly selected car accidents and notes that teenagers were at the wheel in 82 of them. Construct a 95% confidence interval for the percentage of all car accidents that involve teenagers. Okay, first of all, we want a 95% confidence interval for the percentage of all car accidents. Now, that's the entire population. You're not going to build that on statistics from a full population. You're going to build it on statistics from a sample. Okay, so what's my sample? Well, first of all, N is 500, because it says there, an insurance company checks guard records on 500 randomly selected car accidents. That's a sample. So there are 500 objects in my sample. Now, out of that 500, you'll notice 82 of them had teenagers at the wheel. So that's going to be your p hat. That's going to be the positive fraction out of 500, which is 82 out of 500. What you immediately then always write down is what 1 minus p hat is, because 1 minus p hat is 1 minus 82 over 500, which I hope you'll notice is 418 over 500. So there's the fraction that represents the successful crashes. I know it sounds terrible, but that's what it is. P hat, it's the fraction representing the crash. 1 minus p hat is the fraction that represents no crashes. All right, so now you've got the three things I told you to get when you're doing these questions. What do we want to do with them? Well, first of all, let's build up the standard deviation, or the margin of error on the standard deviation. The margin of error is equal to 1.96 times p hat by 1 minus p hat all over n. Okay, remember the standard deviation is just the square root of p hat by 1 minus p hat over n. That's the standard deviation of the sample proportion. The margin of error is 1.96 times that, and the 95% confidence interval is equal to the success fraction plus or minus the margin of error, 1.96 times the square root of p hat times 1 minus p hat all over n. So all I've got to do now is fill these three things here into this fraction. What's p hat? It's 82 out of 500 plus or minus 1.96 times the square root of 82 over 500 multiplied by 418 over 500 all over 500. Now you'll be delighted to know that your calculator will do this for you. So first fraction, 82 over 500. Turn it on, put in 82 over 500. Now put in minus, because we want to get the lowest number first. So we're going to build our 95% confidence interval. Okay, lower number first. So 82 over 500 minus 1.96. Then just press the root sign, press fraction and press fraction again. 82 over 500 multiplied by, so brackets, fraction again, 418 over 500. Close that bracket, go down to the bottom line, put in your 500. Whoops, and make sure you put in your 500, not 50. 500, and then go out twice. Answer, lower number, 0.06136. Okay, so that's the lower number. Then just go back in the fraction, see it there? Just go back in that now and change your minus to plus. So change that minus to a plus, and that'll give you the upper term in your 95% confidence interval. And that becomes 0.2666. Okay, now what does it say? Construct a 95% for the percentage of all car accidents. Well, that's going to run between 6.1% up to 26.7%. But as part B says, what does it mean? It means the following. Based on the sample proportion of car accidents involving teenagers, we can say with 95% confidence that in the entire country, between 6.1% of crashes and 26.7% of crashes involve teenagers. That's exactly what that statement means. Okay, so in other words, it does what it says on the tin. It gives us an interval inside which we can say with 95% confidence the population proportion is residing. Okay, next question. Page 155, question 6. Sea Ferry Limited is exploring the possibility of offering a ferry service between two coastal towns provided that there's sufficient demand. Okay, waffle. The company randomly interviews 200 commuters. Now, Is 200 commuters the entire population of Ireland? No. So we're dealing with a sample. So n equals 200. 130 of them indicate that they would use the ferry. So that means out of that sample, the fraction representing success is 130 out of 200, which means 1 minus p hat is going to be 70 out of 200. It's very simple. Once you work out the fraction representing success, you take it away from 1 and you get the fraction that represents failure. Okay, and there's the 3 pieces of information I need. Part A, estimate the population proportion P of commuters who would use the ferry service. Now, we can't get the population proportion P, but we can get the sample proportion P hat, which I told you is the best point estimate for the population proportion. So if you haven't got the population parameters to hand, then just go with the sample statistics. Simple as that. So I can't get P, but I can get P hat. And P hat is nothing more than 130 out of 200. That's it. That's part A finished. Done. Part B, construct a 95% confidence interval for P. Well, what is the 95% confidence interval? Here it is. It's the fraction of success plus or minus 1.96 times the standard deviation of the sample proportion. What's the standard deviation of the sample proportion? It's the square root of p hat by 1 minus p hat all over n. Okay, just fill it in. So it'll be 130 over 200 plus or minus 1.96 times the square root of 130 over 200 multiplied by 70 over 200 over 200. And that's going to give me the upper and the lower end of my 95% confidence interval. So let's do the same again. Fraction on 130 over 200. This time get the lower one first. So minus 1.96 times the square root of pressure fraction twice to get the upper fraction, which is again 130 over 200. Then brackets fraction 70 over 200. And pressure keys slowly, because sometimes when the more you put onto a screen, the slower the actual computer gets. Computer, calculator, all over 200. Okay, and then out twice, press equals. And the lower percentage is 0.5839. Now, I normally always take 4 numbers after the decimal point, purely from the old days when we had log tables and we didn't have any calculators. All numbers were given correct to 4 decimal places. I do the same thing. The books do the same thing. I want you to do the same thing. It's good and accurate. Okay, and then just go back and change the minus to a plus. So again, look, you have that. That's on your screen. So change the minus to a plus. And when you do that, the second answer is 0.7161. 0.7161. So construct a 95% confidence interval for P. What does it mean? Here's what it means. That based on my sampler proportion, I can say with 95% confidence that between 58.39% and 71.61% of people would use the ferry service rather than the bus service. Apologies for that. I got cut off at the end of that video. The computer just decided to close down, stop recording, go back into restart mode. Why? Updates. Our favorite Microsoft updates. Anyway, I hope you got the end of that question. So this is part B of the remaining section on the sample proportions, and it's only about 5 minutes long. I'll try and tie them together. If not, I'll have to put them up as a double video. Anyway, not to worry. So this is page 156, question 12, carrying on from what we said a few moments ago. In a survey of N students, 600 said they owned a smartphone. A 95% confidence interval for the proportion of students owning a smartphone was given as 0.35128 at its lowest and 0.39872 at its highest. How many students were surveyed? Now, another way to say that, calculate N, find N, okay? But we've got to make sense of what they're telling us in that paragraph. 600 said they owned a smartphone. Now, how many were asked? We don't know. So therefore, that's 600 over N, okay? And that's P hat. So P hat is equal to 600 over N, which means that in here, in this 95% confidence interval, we should be able to find out what p hat is. Now I want you to think about this. 0.35128 and 0.39872 are the boundaries of the 95% confidence interval. Now what are they? This one here is p hat minus the margin of error. This one here is p hat plus the margin of error. So guess who's in the middle? If this is p hat minus the margin of error and this is p hat plus the margin of error, then in the middle here should be just p hat. See? Which means if I add these two numbers together and divide by 2 to get their mean, that should give me p hat. And all I do then is I set p hat equal to what I said already, 600 over n. So let's see, 0.35128 plus 0.39872 is equal to 3/4, which when you divide it by 2 becomes 3 over 8. So therefore my p hat is 3 over 8. Okay, I hope you all understand that. If the lower number in my 95% confidence interval is the positive fraction of the sample minus the margin of error, and the biggest number up here in my range or in my 95% confidence interval is the positive fraction of the sample plus the margin of error, well then in between those slap bang in the middle should simply be the positive fraction of the sample proportion, or the sample positive fraction of the sample, which is we call the sample proportion, p hat. Okay, so p hat is slap bang in the middle, which means I add these two together, these two values here, divided by 2 to get 3 over 8. Now what does that mean? That is p hat. P hat equals 3 over 8. But we also said up here, from the information that I was given, that p hat is 600 over n. So what does that mean? Do the cross multiplication. That gives me 3n equals 6/8 are 48. So therefore when I divide by n, I get 1600. So there were 1,600 students in the survey. That's it. Part 2. If the margin of error for a 99% confidence interval is given by E99 equals 2.575 times the standard deviation of the sample proportion. Okay, remember what I told you earlier on. If you're asked for any other confidence interval, they will have to give you the number that you multiply the standard deviation by. The only number you have to remember is for the 95% confidence interval, which is 1.96. Any other confidence interval has a different multiple in front of the standard deviation. In this case here, in front of the standard deviation of the sample proportion, Yeah. Okay, so let's take a look and see. 2.575 multiplied by, so we have this now, we have p hat. We know that p hat is 3 over 8. That means that if p hat is 3 over 8, let's just write down everything. P hat equals 3 over 8. That means 1 minus p hat is equal to 5 over 8. And then n is equal to 1600. We just worked it out a moment ago. So now, using this formula here, we get 2.575 multiplied by 3 over 8 times 5 over 8 over 1600. Okay, now what's that? That's the margin of error. But what's the 99% confidence interval? Well, it's p hat plus or minus that margin of error. Okay, so if they want the 99% confidence interval, you work out the margin of error and you add it and subtract it from the, what we would say, the successful fraction, the fraction representing successes out of your sample. So what does that become? P hat is 3 over 8 plus or minus 2.575 times the square root of 3/8, which is p hat, 5/8, which is 1 minus p hat, over 1600. So to work this out, get your calculator, turn on your fraction, put in your 3/8, put in your minus first of all because it'll give you the lowest number. 2.575 times the square root of fraction, press it twice. So 3 over 8 is your first fraction. That's multiplied by 5 over 8. And that, in turn, is over 1600. So the answer, as far as the lowest one is concerned, is 0.34 0.38. And the highest number, just go back and change the minus to a plus, and that comes out as 4.4062. So that is your 99% confidence interval. Now, what does that mean? Say they asked you part C, explain what this means. What does that mean? Well, this is a 99% confidence interval is equal to that. What does it mean? It means that with 99% confidence, I can say that the percentage of students owning smartphones in the population is between 34.38% and 40.62%. Now, you probably notice the higher the confidence interval, the wider the range, which makes perfect sense. Because if you want to make sure to a degree of 99% that you have caught the population proportion, then you have to spread the net as far as possible. If you bring down the confidence interval, well, then you've got to make sure that your range is a little narrower. So the lower the confidence, the narrower the range. The higher the confidence, the wider the range, for a very simple reason. 99% confidence, wide range. Why? Because the wider the range, the more chance you have of actually including the figure that represents the population proportion. Okay. Now that's what I wanted to do at the end of that video, which cut me off so rudely in the previous part. So I'm going to leave you with these to do. There's only one more thing to do after that now. That's hypothesis testing, which is quite straightforward. But I want you to work on these first. It is vital that you get to grips with all the different formulas, the different types of standard deviation of a population, standard deviation of a sample, standard deviation of a sample proportion, and so on. It's vital that you get to grips with those and you know how to use them and when to use them. Okay. And then the 95% confidence interval with the 1.96 times what we would say the standard deviation of whatever particular set of statistics you're using. So I want you to work away now, please, on page 155, 156, these questions here. And again, if there are any difficulties with these, send me on the question number and the page number, and I'll send you back the solutions.